So you've got your lab set up. You've got your reference machine set up. It's not connected to any network because remember, in this dynamic analysis, you could infect your network. After you're finished, by the way, before we talk about the process, after you're finished, you need to destroy this virtual machine. Now, here's one of the problems with binary dynamic analysis. Some binaries look at the fact that they're inside a VM and they won't run. So if you execute and nothing happens, you may need to put this on a physical machine, and then now you're rolling images down. You're using something like Ghost or something like that to build this reference image and actually install it on this machine so that it's real hardware, because it'll say, well, a VM's present or I'm inside a VM. I'm not going to show you anything because you're trying to study me. So I'm not going to show you. Okay, so now you realize that that could happen. The normal process is launch your snapshotting tool and then enable all the real-time monitoring tools that you're going to have on this system. Launch or install the executable, in other words, run that program, and then snapshot it afterward. The difference from before and after in the snapshotting tool should tell you all the registry settings. It should it should tell you what files were trickled throughout the machine. If it actually went and uncompressed itself in some way, shape, or form and got rid of the encryption and actually ran in memory and then went and installed different files in different places, the snapshotting tool will tell you that. A lot of other tools that we have, like the file integrity checker, it may be that inside of this executable that we have right here, it may replace some key executable on the machine. And with the file integrity checker, we go back to the machine and we say, okay, this ntoskernel.exe has this hash value on it. The file integrity checker knows what that hash value is, and then when we go back into the file integrity checker and rehash that particular executable, it's different. So now the file integrity checker says you've got a different running OS. That could a different executable on the machine, and that could lead us to knowing where the malware went to. So now you've got the snapshot of that. Also, did it phone home? That's why you listened on the network card, but you don't have any real attachment to any kind of outside interface. So Wireshark outside of your machine, maybe to another terminal where you've got a crossover cable between these two isolated machines, just so that you can listen for it phoning home. If it sends any executables up the wire, it's not going to give you the full, rich, robust communication with that other host, but you can't afford to test that at this point. That's the normal process for what we're doing. Now, there's a whole study in this. It's called reverse engineering malware, and it's much more sophisticated than we've talked about here, but this is the first step in this. We're dipping our toe in this pool. So remember, you're retrieving the logs, the registry snapshots, the file integrity checker data, and if you're using an MSI tool, an MSI builder, it will actually tell you all of those changes that are on that particular machine. And that's the data that you're going to retrieve for your individual forensics analysis. So now we've talked about dynamic and static analysis for an individual file. And next we're going to talk about some of the other settings on the machine that give us some good artifacts.